I will now present the work related to the fatigue topic that unfortunately Dr. Kalle Lipiäinen from my group wants to present it, but then he could not attend this meeting now due to other applications, and then I will present it now. The topic is in continuation of some presentations that we have seen today, and then we will continue that discussion in some way. And then, as you probably seen that about the activities that we have the different facilities that we want to try to study them, and then for that purpose, one of the key issues is fatigue. And then, as you can see that in all of these conditions that you can see that we can use this hydrogen, then we have the fatigue condition, but then with different frequency, with different lifetime expectation, and also with different stress level that we have. And then in that case, I have shown that already that our current instrumentation for testing, that I can skip it, but then absolutely we have this big range of ability to testing the different materials with different stress level. And then the point is that regarding the fatigue testing approaches, as also we have the some of the presentations, I think today and also yesterday, the point is that we have big interest for testing the materials in different conditions depending on the application. For example, high frequency fatigue testing is something that that we are recently approaching to that as a one new method that can reduce our work. I think Romo company also has this place here that they are also manufacture this device here for us. And also the low cycle fatigue test is also another possibility that we are using that for testing the different materials. The point is that also this can be a faster test, but then absolutely can rank the materials with the regular dipole experiment if you want to do that. But then the popular one that we have also some presentation related to that is fracture mechanic testing, that then we can break it to several types, that then I stress that a little bit now here on the J integral test. And then also we have this hydrogen assisted crack growth rate testing, LEFM, that is the most popular one that we have seen that also some presentation also results related to that. Then we can see the crack growth rates depending on the number of cycle, and also you can see that how the delta K stress intensity factor can be changed. And also then the other option that then we have this full scale test. The full scale testing means that you have this component and also you want to test it in real condition directly. And then this is also something that can be very interesting because testing of material itself is some things, but then, for example, let's imagine testing of a pipeline in full scale. That is providing us some more results and also some different input. But then in that way, for the setup that we have, other than the regular setup that I have shown you, is testing the different cycles that we can, the different specimens in different cycles with the dark bone specimen that you can see here. And also we can predict and see that how the fatigue life can be changed. Also, in the meanwhile, also we could also follow up the change of the temperature and also the change of the work that can be introduced by plasticity or by friction. Then we can also reach to a lot of information about the generation of entropy that we already published in this paper that you can see here, that we explained already about this hint mechanism. But then when we want to see one of those cases that we used about this linear elastic fracture mechanics, and also how we can finally use them for design and testing the hydrogen pipelines, that is a very important point that we are looking for. That this is the part of hydrogen and carbon value chain project in Finland that is now approaching to the final phase now, and then we could provide with some new measurement methods and also establishment of prediction model for this case. And also the main indicator, as you know, that in pipelines is pressure fluctuation. This pressure fluctuation is provided by pumping, and then this can provide this very low frequency of stress that you have that, and also then you will expect that a very low frequency with the probably very high number of cycles that you have it. But then also the stress here is also explained here and also then evaluated. And then more calculation data and also details is can be found in this paper that is published in International Journal of Hydrogen Energy this year. And then also for that purpose of this study, we finally have to connect these results with another approach that we need to complement it with the weld, because then we felt that at the end of this project that then the testing of the weld is also very important in this case. And then we also prepared that a similar sample also with the weld, that is now this is the ongoing project that we are now doing, that is together with the SSAP Europe, that we are trying to do the test and also complement that. Then you can see that this we are doing a lot of analytical tests, as you probably seen that in many presentations, and also finally we could connect that to the results of LEF. But the main point is that the detailed analysis of this crack growth rate is very important, and also how we can collect the data and also can index. Also, we could see that the point is the small variation in this crack growth rate can be super important for us, and also the amount of delta K that we can reach in different cases can be also important. And also according to the rules that we have here, like this Paris law and the others, then we try to also break it to much more detail and also predict it. The point is like the other presentation that we have also tomorrow from another postdoc in my research group that he will present that about the accommodation of all this data together and also comparing them with different steel pipelines, and also try to use that also AI for evaluating those data. And then for that purpose also, as you know, that when we reach to some values like the K1C, that we can calculate that based on the stress intensity factor that we can measure. Finally, that is also a number that provided by some standards that like that SMB 31 that you can see here, 31.12. That then we have this specific number that with this crack growth. I think this is also bounded with the previous GCMB test that I think from Tigras they presented. And then the point is that how this crack size can be relevant and also can be pointed with its standard. From my viewpoint, this standard is getting that a very open criteria, and then there are lots of materials that can sit inside that. But while we are testing them in real condition, as I think Chris also mentioned, some of these materials will not work actually in the long term. And then, but then this criteria is somehow getting that very open. But then absolutely we are trying to first to see that how we can approximate these linear elastic fracture mechanic results there. And then if you want to break it down about this data from the crack growth rate, that we can see that we can approach this with the one-stage Paris law. That is also, I think, that is similar things that you always know that all the mechanical engineers knows it. But then if you want to reach to the point that then we suggested this two-stage variation of that. Then in that case also we can see here that is we can have these the two parts that based on this stress intensity factor, and then we can make this prediction much more viable. Then based on our database and also the evaluation that we have here, then we can see that how this phase 1 and phase 2 can be calculated based on this numerical model that we can fit into our real data. Okay, then this fitting will also consider that the finite element calculation, that we can see that how much of the stress we have that at the peak and also at the tip of the crack, and also we can see that how the crack will be extended and also controlled based on distribution of the stress around it. And then after all these considerations, we could reach to this schematic that you can see here, that a little bit like general guideline for industries, because the project is related to the industries, and then how we can rank them and also show that which part and also which specific properties of the material can be important. But then absolutely the main point here after our model that we can see here, this is the initial crack size in pipeline. That is super important. That is, when we want to discuss about these current existing pipelines, then we need to look to that. But absolutely, there are lots of questions about that. Okay, what is this criteria for that, or how we can say it or bring that to the good inspection by these different NDT methods. But then the question is that most of the existing existing oil and gas pipelines that we are trying to repurpose them for hydrogen is not working. Then this crack size, while that can be very important, but then this can be considered also in another cases. Then you can see that depending on the time, we have the different importance here. Then the important part here can be that these fracture toughness topics and also materials that to be whitelisted. And also between them, we have these different variations. That is also the growth rate of the crack. That is also very important one. And then, as you can see, that is the industrial inspection method or consideration that we try to simplify our output. But then it doesn't mean that we could reach or we could give the green light to use all this existing pipeline. And then the main things is that try to monitor that how the industries are doing their things. And also the output of our data is also here, that we can see that the fatigue life as a function of pressure, that you can have this in a specific size of the pipeline that you can see here. And also we have the pressure cycles here that we can see here, and also the pressure range. Also, we consider that the mixture of the methane here, that is also coming out from some of the tests that we did in the mixture of the gas of H2 plus methane. That is also very important. But then absolutely the lines that you can see here that can show us how the different criteria can work here, and also how we have the different prediction method like this two-stage that I mentioned here, and also with the regular estimate. That is absolutely now here we can see that the fatigue life that here is considered a reasonable one is not easy to meet in different range of pressure, especially in higher. And then absolutely here is also our two-stage method is working much better than this regular estimate. And then I think in that case, we need to also consider the replacement or correction of this standard in future. However, I can admit and also comment that at the moment, use or also if we have another revision of this ASME standard, again, it cannot be easily applicable directly, because then we are lacking a little behind of the required data for the purpose of this study. And then the final message of